Hello everyone, I am Dr. N.Senthil, Associate Professor Computer Science Engineering. Great pleasure for me to welcome you all for this session. This session topic to be covered is elements of parallel computing under Unit 1, distributed and cloud computing. At the end of Unit 1, the students will be able to describe the core features of parallel and distributed computing in cloud. At the end of this session, the students will be able to understand the elements of parallel computing. What is parallel processing? The processing of multiple tasks simultaneously on multiple processors is called parallel processing. The parallel program consists of multiple active processors simultaneously solving a given problem. A given task is divided into multiple subtasks using a divide and conquer technique, and each subtask is processed on different central processing unit. Programming on multiple process system using divide and conquer technique is called parallel programming. Many applications today require more computing power than traditional sequential computer can offer. Parallel processing provides a cost-effective solution to this problem by increasing the number of CPUs in a computer and by adding an efficient communication system between them. The workload can then be shared between different processors. This setup results in higher computing power and performance than single processor a system offers. Now we will see about hardware architectures for parallel processing. The core elements of parallel processing are CPUs. Based on the number of instructions and data streams that can be processed simultaneously, computing systems are classified into following four categories: single instruction single data systems, single instruction multiple data systems, multiple instruction single data systems, multiple instructions multiple data systems. Single instruction single data computing system is a uniprocessor machine capable of executing a single instruction which operates on a single data stream. The machine instructions are processed sequentially, hence the computers adopting this model are popularly called sequential computers. Most conventional computers are built using SISD model. All instructions and data to be processed have to be stored in primary memory. The speed of the processing element in the SISD model is limited by the rate at which the computer can transfer the information internally. Dominant representative SISD systems are IBM PC, Macintosh, and workstations. Single instruction multiple data computing system is a multiprocessor machine capable of executing the same instruction on all CPUs but operating on different data streams. Machines based on this model are well suited for scientific computing since they involve lot of vector and matrix operations. For instance, statement Ci equal to Ai into Bi can be passed to all the processing elements organized. Data elements of vectors A and B can be divided into multiple sets, and each processing element can process one dataset. Dominant representative SIMD systems are Crace Vector Processing Machine and Thinking Machines (CM) and GPGPU accelerators. Multiple instruction single data computing system is a multiprocessor machine capable of executing different instructions on different processing elements, all of them operating on the same data set. For example, y equal to sin x plus cos x plus tan x. Machines built using MISD model are not useful in most of the applications. Few machines are built, but none of them available commercially. This type of systems are more often intellectual exercise than a practical configuration. Multiple instruction, multiple data computing system is a multiprocessor machine capable of executing multiple instructions on multiple data sets. Each processing element in the MIMD model has separate instruction and data streams. Hence, the machines built using this model are well suited to any kind of application. Unlike SIMD MISD machine, processing elements in MIMD machines work asynchronously. MIMD machines are broadly categorized into shared memory MIMD and distributed memory MIMD based on the way the processing elements are coupled to the main memory. In shared memory MIMD machines, all the processing elements are connected to a single global memory and they all have access to it. Systems based on this model are also called tightly coupled multiprocessor systems. The communication between processing element in this model takes place through the shared memory. The modification of the data stored in the global memory by one processing element is visible to all other processing elements. Dominant representative shared memory MIMD systems are Silicon graphics machines and Sun IBM SMD. The SMD is symmetric multiprocessing. In distributed memory MIMD machines, all processing elements have a local memory. Systems based on this model are also called loosely coupled multiprocessor systems. The communication between processing elements in this model take place through the interconnection network, that is Inter-Process Communication Channel or IPC. The network connecting processing elements can be configured to tree, mesh, cube, and so on. Each processing element operates asynchronously, and if the communication or synchronization among tasks is necessary, they can do so by exchanging messages between them. The summary of this session is we learned various elements of parallel computing such as single instruction, single data system, single instruction, multiple data systems, multiple instruction, single data systems, multiple instruction, multiple data systems. I hope you found this lecture is more useful. Thank you and have a pleasant day.